Hello. I'm very privileged to be able to speak again to one of my favorite people, Gene Dolgoff. And Gene, I know you're doing a lot of work on cancer research. If you could fill us in on that, I'd very much like to hear it.
I am very fortunate now to be working with a team of 16 doctors, surgeons, oncologists, radiologists, scientists, to develop this new concept, which I actually started working on back in 1969. And through the years, it's progressed slowly, and it's accelerated in the last year with this wonderful team. We're developing a completely new kind of treatment for cancer. The way that cancer has been treated up to now has been with what's called the gold standard, which is a combination of surgery, radiation, and chemotherapy. And it's somewhat successful. It depends on how early you catch the cancer, how successful it is. And sometimes people actually do get cured, only if it's caught very early. But usually what happens is it's delayed, its progress is delayed. So you get extra time, and the extra time you get could be from a few months to decades, which is terrific, but it's still not the whole life that you expected. So it's got a lot to be desired, and it also comes with a price. I mean, there are a lot of side effects, and it's disfiguring, and there's many complications. What we are developing is radically different. There's no need for surgery, there's no need for radiation, there's no need for chemo. Instead, we're using nanotechnology, which has been in the news for decades. Nanobots coursing through your body that fix the problem. Well, it's sort of like that, but not exactly. Okay. So we do inject nanoparticles into the bloodstream, and they are a few billionths of a meter in diameter, so they are very small. But they are bioinert, so they don't do anything bad to the body, and they consist mainly of iron, which we have in our blood, so it's not a problem anyway. These are not really robots, so it's not really nanobots, but they are going to do some very specific functions. The problem with the concept of nanobots, as the press has talked about for decades, is that you can't put such a complex mechanism that's capable of doing some complex task into this small space. Plus, you can't get enough energy into this small space to power such a device. So we don't do that. What we do is we put these dumb particles in that are constructed in a certain way so that they can take input externally, from external information. So now you have this coursing through your body, and they are covered by certain chemicals that cause them to seek out whatever we want them to seek out. So for instance, if you have pancreatic cancer, which today nobody knows how to detect, and it doesn't have any perceptions that it creates, so by the time there's some kind of a bad thing happening, it's way too late because it's progressed too far, and that's why most people die from pancreatic cancer. Well, this could be a routine test that everybody goes through. The nanoparticles go through the body, and using what's called monoclonal antibodies, it seeks out the tumors that are cancerous cells of the pancreas, and it attaches to them. When it does that, we now can scan you from the outside and detect those particles because of what those particles have in them. And we get a three-dimensional image of where those particles are within your body. So if you had a pancreatic tumor, those particles would accumulate there, and we would get a 3D image right there telling us, oh, there's a tumor there. And metastasis happens whenever you have a tumor, and sometimes it happens immediately. So that means a couple of cells break off and go through the blood system or the lymph system, and they go somewhere else and deposit themselves and then grow tumors in other places. Well, our particles will find it wherever it is. And this is so important because metastasis is responsible for more than 90% of the deaths from cancer. Not the primary tumor, but the metastasized tumor.
Yes.
This will locate them wherever they are in the body, and this of course will work with any type of tumor, so it doesn't have to be pancreatic cancer. So now we get a three-dimensional holographic image of exactly where in the body these things are. Now the best part is the next step. We then send energy into the nanoparticles, and that energy causes the nanoparticles to heat up. Only a few degrees, but enough so that the cancer cells can't take it, and the cancer cells therefore die. Now, the big hurdle was, how do you get that much energy into the body without damaging the body? And that's always been a big problem, for instance, with radiation therapy. You sending in powerful radiation, whether it's X-rays or gamma rays, or even if it's protons, you're still going through healthy cells and you're going to damage them. So how do we get all that energy in without damaging healthy cells? And we do it by using holography. Holography reconstructs energy in the locations in space that you want to be reconstructed. But in the areas where you don't want it, there's what's called destructive interference, which cancels the energy. So the energy goes into the body, but because the beams are overlapping, they cancel in terms of effect. So the body perceives no energy, even though the energy is there, except at the tumor location. Then the energy is no longer canceling, and we have what's called constructive interference. The energy is now addressing the nanoparticles, causing them to heat up and do their work. But meanwhile, the healthy cells don't get damaged at all. So that's the basic basis behind this radical new way of treating the cancer.
That's extraordinary. I mean, this is disruptive technology with a capital D. Where are you, or what do you need to develop this technology and bring it to market?
Well, we have a great team that has done a lot of research on the individual steps. For instance, work has been done with mice and with dogs, showing that the nanoparticles will heat up and will absolutely kill the cancers, and that's been shown. We have dogs. Vets for these dogs gave up on these dogs and allowed us to do some experiments, and we did the experiment with this type of treatment with the nanoparticles, heating up the nanoparticles. The cancers were cured. They were completely eliminated. So instead of dying from the cancers, the dogs died of old age much later. So it's very important to understand that when a tumor forms, it doesn't necessarily always form as one lump. It often forms as a web of tumor cells that surrounds blood vessels and nerves and muscles. So it's not like you can go in there and just cut out the cancer cells. It's too intricate. You can't do it, which is why so many times you just have to do a mastectomy, or you have to amputate a limb. It's a terrible thing, and yet it's not necessary, because all you have to do is this process. It will selectively kill those tumor cells and leave the healthy cells alone, and then you won't need that kind of destruction to take place.
Wow. How far away do you think we are from this essentially eliminating cancer?
Yeah, what we need to do is we need to finish building the new equipment so that we can make it a complete system that it becomes available to people. Initially, we're going to be doing this outside of the U.S., gathering a lot of data. Then we'll be submitting it to the FDA, and we'll use a fast-track method, which some of our people are very familiar with and very good at, so that we can get this FDA approved. So if we can get the funding we need to build the equipment and to do the clinical testing, I think we can get to the point of FDA approval in a 5-year period, which is an incredibly short period of time for
Absolutely.
a new technology.
And are you set up to get the funding, or what kind of funding do you need?
Well, we're doing a crowdfunding offering right now, and it's very small. It's just a $100,000 crowdfunding effort, and it should be very easy and quick to do. That'll allow us to make a feasibility demonstration, and then we'll raise the bigger amount. We need to raise $10 million to be able to get to an actual clinical system. So that will probably be done with venture capital and other types of investors, and who knows, maybe a public offering, I don't know. But also we're setting up a 501c3 so that we can take donations as well, and they will be tax deductible as usual.
Very good. Well, that's very exciting. Anything else you can think of that we should know about the work you're doing?
Well, it's a whole new paradigm, and it's very, very important, because even though you may think, I'm not going to get cancer, I feel fine, the statistics are that cancer is the fastest growing disease on earth. It is the number 2 killer of everybody, but it is the number 1 killer of people aged 45 to 79 and all children under 19, number 1 killer. 1 out of every 2 men and 1 out of every 3 women will get cancer in their lifetime. There's no question about it. So everybody is going to be touched by cancer, either personally or a loved one, a family member, a pet, and the prognosis is bad because, for instance, in 2016, there were 1.7 million new cases of cancer and over 600,000 deaths. It is rampant. In the next 2 years, there will be more deaths than all of the wars that we fought in worldwide combined.
Wow. Gene, I really want to thank you for the work you're doing. Just personally, it's fascinating, but it makes a difference.
Thank you so much. I appreciate you letting me have the opportunity to talk about it. It's so important.
Well, I'm looking forward to a lot more. Thanks.
Thanks.